Now, a concept that initially gave me a little bit of trouble was parallax. But once I explained to myself exactly how parallax was significant to astronomy, and I actually gave myself a couple analogies that I may have experienced in my own everyday life to help better understand it, I understood how vital this concept was to astronomy. Now, for example, whenever you go to the optometrist or the eye doctor to get a checkup, at some point he may ask you to, sit in this chair and cover one eye and read the board in front of you. Now, when you do that, you get to a certain point and then you switch eyes. Now, when you do that switch, you may notice that there's a shift, actually, in the image that you viewed. And that's because as human beings, having two eyes, we have overlapping visual fields. And this, we use these visual fields in the parallax we get from them to gain depth and perception. Now, once I understood that, I was able to better place the concept of parallax into astronomy and how it's vital to astronomy. With parallax, and by the laws of parallax, we can measure and determine distances and depth. This concept is so vital to astronomy that astronomers use parallax and what we call stellar parallax to measure the distance of celestial objects like the sun and other stars, or even the moon and their comparison to Earth and Earth's orbit. Annual parallax is actually normally measured by observing the position of a star at different points of the year as compared to the Earth and how Earth moves throughout its orbit. So, by explaining the laws of parallax in relation to how human beings, we experience it in everyday life, this allowed me to understand this concept and its significance in astronomy, and I'm sure as a professor it would definitely aid one in doing the same. And it really honestly did when Professor Slagle helped us with that chicken video in class, showing us how the chickens cluck and they move their heads to gain depth because they have their eyes on two different sides of their head, so they can't use a joint parallax. So in understanding this concept better, I realized, astronomers use this principle very often of parallax to measure the distance of the moon, the sun, and other things significant to us in the solar system, and even things outside of our solar system to see, how close we may be to other objects or I should say galaxies or anything of the sort. And that's my spiel. Thank you.